Hello everybody, this is Mr. Bowman. Today we're going to be looking at slope and trying to figure out what's going on with that. So this is going to be our topic for a bit now. There's a lot going on here in different ways we can look at it, but it really breaks down to a really simple concept. Slope is how much something is increasing or decreasing, or in terms of lines, how much it's tilted. Okay, so how we're going to talk about this is we need some vocabulary to see what we're talking about. So if I have a couple of graphs here so you can see what I'm looking at. If we're looking at a line like this that is going up from as we go left to right, so it looks like kind of an uphill slope. I shouldn't use the word slope there, but it looks like it's going uphill if we're going this way from left to right. Then this is a positive slope. Okay. If I have the opposite, and from left to right I'm going down, like a downhill slope, this is a negative slope. And if I have something like this would be zero slope, okay, because it's not going up or down. But we're going to talk more about zero slope later, but just so you know kind of what we're looking at there. So how I like to think about this is the slope of a line has to do with two things. One, how much fun it would be to sled down, or ski down, as the case may be, whatever you prefer, and what direction we're going. So this one is a positive slope. That tells me direction. But which one would be more fun? This red one or this blue one, if we were sledding down it? So this one's steeper, right? Which, in my mind, makes it more fun. So this one would have a higher slope than this one does, similar to this one would be steeper. It would be really kind of starting to get dangerous here, but would be has a higher slope than this negative one does in terms of its absolute value. Okay, and zero is zero. It can't really tilt it at all. Okay, so in order to really start figuring out a way to measure this, so we don't just have this one's more steep than this one's less steep than this one, so this one should have a higher slope and lower slope. We need to start putting numbers in here. So what we do is we talk about how much the y value changes, so the change in y, and then we divide that by the change in x. So what that means is for any given break, say if I'm going from here to here, so from 0 to 1, is my y value changing more or less? Okay. So if I think about it in terms of a hill, if I'm going here, if this is my hill, and this is, say, 1 foot, and this is 1 foot, which one's going up more in that 1 foot than the other? So this one's going up more, so it would be a higher slope because it's steeper. This one's going up less over the course of 1 foot, so it'd be less steep or have a smaller slope. So the change in y over the change in x. Now, that is not the only way we write this. Change in math eventually starts using a symbol called delta, which always stands for change. So delta y over delta x, that's the fancy version if you want to do that. Or one of the ways they do this a lot is they refer to it as rise over run. Okay, so rise is how much we're going up and down, run is how much we're going left and right. So rise is up and down, and then run is left and right. Okay. So when we're actually going to try and figure these things out, if it's on a graph, that's fantastic. It makes it a little bit easier. Sometimes it's not on a graph, and we're going to look at both of those scenarios and see what to do here. So let's say I have this line. So first thing I want to do is I want to see, is it positive, negative, or zero, because that'll give me a starting point. Okay. So this one is going downhill rather sharply, but it's going downhill. So as I'm going, because remember, you're always going from left to right. So as I go here and go along my line, I'm going down. So this is going to be a negative slope. And we're going to use m to stand for slope. We'll get into more of that later. But m equals something. So to figure out what that something is, I want my change in y. So you can pick any point and go to any other point if it's a line, and it should work. So I'm going to go down here and then there to get to those 2 points. So how much am I going down? I'm going down 1, 2, 3, 4, 5, and it's down 5, so that's negative 5. Because remember, down and left are going to be negative. So this one, then I'm going right 1, which is positive because it's right. So in this case, I'm looking at the change in y and then over the change in x. So my change in y was negative 5. My change in x was 1. So my slope here is just negative 5. Let's look at another one really quickly. Maybe a positive one this time. Okay, so if I look at this one, I'm going to have a new slope for this line. And it doesn't really matter, so I'm going to go from here to here. So in this time, I'm going left. So I'm going left 1, 2, 3. So left 3, left's negative, so negative 3. And down 1, down is also negative. So my change in y, be careful here, it's not necessarily the order you figure them out in, but y is right here. So negative 1 divided by my change in x, which was negative 3. I want to clean up, they're both negative, so my slope for this one would be 1/3. Okay. So it's all counting and being very careful with your negative signs. If you have 2 points instead of a graph on a line like this, let's say I want to find the slope between 3, 1 and 2, negative 7. Okay, the points don't actually matter all that much. So if I want to do that, I want the change in y and the change in x again. So what I need to do is look at this and pick either one. It doesn't really matter, but I'm going to start with this one. And what is my change in my y's? Okay, so how far do I go to get from 1 to negative 7? If you remember when we did the distance formula, that's just subtraction. So I'm going to do, you'll see why I'm doing this in a second, but I'm going from 1 to negative 7, so I'm going to do right minus left, negative 7 minus 1, which is negative 8. So I'd go from 1 to negative 7, I'm going left 8. So that's my y's. For my x's, I'm going to look here. So I'm going from 3 to 2. So 2 minus 3 is negative 1. So I'm going down 8. Got my directions wrong there. Down 8 for this one. I'm going left 1 to get from 3 to 2, because that's x. So when I put these together, I get negative 8 over negative 1, which is just 8. So my slope would be 8 for this one. So a lot of people don't like having to reason their way through stuff every single time because it gets rather exhausting. So there's a formula you can use that basically breaks down this exact process. So let me get 2 new points. Let's go from 0, 3, and I'm going to go up to 4, 8. Okay. So basically the formula is just this all in one go. So it's y2 minus y1 over x2 minus x1. It's the same subtractions we did here. So the y coordinate from the second minus the first over, that's why we divided here, this x coordinate from the second divided by the x, or minus the x coordinate from the first. y2 minus y1 equals x2 over x2 minus x1. That's equal to m because that's what we call slope. All right, so if I plug these in, so second y coordinate is 8, minus the first y coordinate is 3, second x coordinate is 4, first x coordinate is 0, and I just clean it up. 8 minus 3 is 5, 4 minus 0 is 4. There's nothing to clean up here. Your answer is 5/4. Okay, so just take your time. Once again, be careful with your negative signs, and make sure you get the order very, very careful when you plug them in. You should be okay.